Hello developers and DevOps engineers. Welcome to part 1 of our series, Cloudflare for Startups. If you're at a fast-growing startup, you know the challenges of scale all too well. How do you keep your application secure from constant threats, blazing fast for a global user base, and manageable without a massive infrastructure team? Today, we'll explore powerful strategies using the Cloudflare toolkit to solve these exact problems. Here is our roadmap for today. We'll start with DNS and why Cloudflare is a uniquely powerful and cost-effective choice. From there, we'll cover how to secure your origin servers completely. Next, we'll dive into advanced routing, using both host names and URL paths. We'll then introduce the traditional API gateway pattern before showing you how to evolve that concept using Cloudflare. Finally, we'll optimize for a global audience with intelligent geolocation routing. Let's get started. Every application on the internet begins with DNS. It's the phone book that directs your users to your server. But it's more than that. The speed and security of your DNS provider directly impact your users' experience and your application's safety. Now, let's look at the economics of scaling. With traditional providers like AWS or Azure, you pay per domain, or zone, and you pay per million queries. This might seem minor for one website, but consider a modern development workflow. You might have dozens of microservices, each with its own subdomain. You might spin up preview environments for every pull request. The number of zones can explode, and those per zone and per query costs start to add up, creating financial friction for your team to innovate. Cloudflare's free plan offers unlimited zones and queries, removing this barrier entirely. When you first add your site to Cloudflare, you enable the proxy. This hides your IP address and provides basic DDoS protection. But it's not foolproof. Attackers run constant scans across the internet, and if they find your origin IP, perhaps from old DNS records or an email header, they can attack your server directly, completely bypassing Cloudflare's protection. A more secure approach is to lock down your server's firewall. Here, you explicitly tell your server to reject all traffic from the internet unless it comes from one of Cloudflare's own IP addresses. This is a huge improvement and blocks all direct attacks. However, a subtle vulnerability still remains for the most security-conscious. What if an attack is launched from within the Cloudflare network itself? A malicious actor could deploy a Cloudflare worker script. Because this script runs on Cloudflare's infrastructure, its requests would originate from a trusted Cloudflare IP. Your firewall, seeing a valid Cloudflare IP, would allow this traffic through, creating a potential backdoor. To close this final loophole and achieve a true zero-trust model, we use Cloudflare Tunnel. A small, lightweight agent called Cloudflare-D runs on your server and creates a secure, encrypted, outbound-only connection to Cloudflare's network. This means you can configure your firewall to deny all inbound connections, making the worker attack vector irrelevant as there is no open port to connect to. It is the most robust way to protect your origin. As your architecture grows to include multiple services on different virtual machines, Cloudflare Tunnel can act as a powerful internal router. Instead of running the agent on every app server, you can run a single Cloudflare-D instance on a dedicated machine. In your Cloudflare dashboard, you can then route traffic based on the hostname. A request for app1.macloud.dev is intelligently routed to your first app, and a request for app2.macloud.dev is sent to the second. This provides a clean, centralized, and secure way to manage a multi-service architecture. In other scenarios, you may need to expose multiple services under a single hostname. Using the same Cloudflare tunnel, you can configure it to route based on the URL path. A request to /kube1 gets sent to the first cluster's API server, and a request to /kube2 goes to the second. You can even configure a Cloudflare snippet to intercept all the requests with controlplane.macloud.dev hostname. This will help you to configure this snippet as authentication proxy for all the Kubernetes API servers exposed under different paths of this hostname. In many modern architectures, we use an API gateway. Think of it as the front door for your backend microservices. It receives client requests and routes them to the correct service. This is a great pattern because it centralizes common concerns like authentication, rate limiting, and logging. However, the gateway itself is another piece of critical infrastructure. It becomes a potential bottleneck that you have to manage, scale, secure, and patch. This is where we shift our perspective. Instead of managing a centralized gateway server, you can offload all of those functions to Cloudflare's global edge network, which runs in hundreds of cities worldwide. Think about what this means. Sophisticated rate limiting isn't just running in your primary region, it's enforced milliseconds from the user, wherever they are. Authentication using a Cloudflare worker to validate a JWT token happens at the edge, so invalid requests are rejected instantly and never consume your server's resources. You can use transform rules to add or remove headers as requests and responses flow through the network. This isn't just moving your gateway, it's dissolving it into a global, serverless platform. The logic that used to be a potential bottleneck is now distributed, running close to your users. This radically simplifies your architecture, reduces operational overhead, and makes your application fundamentally faster and more resilient. As an application scales to a global audience, we face a new set of complex challenges. It's not just about performance, it's about data sovereignty and legal compliance. Regulations like GDPR in Europe mandate that the personal data of European citizens must be processed and stored within the EU. This means we can't simply send all our user traffic to a single backend in the United States. To solve this, a common architecture is to deploy separate, identical backend environments in different regions. As you can see in this setup, we have a dedicated endpoint for our US users, app1-api-us.macloud.dev, and another for our European users, app1-api-eu.macloud.dev. The challenge then becomes, how do we route users to the correct endpoint automatically? We don't want to build complex, hard-to-maintain logic into our front-end application. Ideally, our application should be simple and only ever talk to a single, global API hostname. This is where Cloudflare provides an elegant solution. We create a global endpoint for our application to use, app1-api.macloud.dev. Now, for Cloudflare to be able to intercept traffic for this hostname and apply logic to it, the hostname must have a DNS record and be proxied. But since this global hostname doesn't point to a real single server, what IP address do we use? This is where the dummy IP comes in. We create a DNS record for it with a placeholder IP, like a reserved address. The IP itself doesn't matter, because no traffic will actually be sent there. Its sole purpose is to make the DNS record valid so Cloudflare's proxy can engage and run our logic at the edge. With that in place, we attach a Cloudflare snippet to this global hostname. This snippet is a small piece of code that inspects every incoming request. It checks the user's country code, which Cloudflare provides automatically. If the user is from a country in the EU, the snippet silently forwards the request to the app1 API-EU endpoint. For users elsewhere, it forwards them to the US endpoint. The user and the application are completely unaware of this routing. They only ever communicate with the one global hostname. This works perfectly to solve our compliance problem, but it means our snippet has to run on every single API call. Let's look at a more elegant and efficient way to achieve the same result. While the simple setup perfectly solves our compliance needs, it introduces a small but constant overhead. Having a snippet run on every single API call adds a tiny bit of latency and increases the invocation count of our edge logic. For a high-traffic application, this can be suboptimal. A more elegant and architecturally efficient approach is to shift our thinking. Instead of having Cloudflare intercept and route every API call, what if we just ask Cloudflare once, at the very beginning, which is the correct endpoint for this user? This is the improved setup. We no longer need the dummy DNS record for a global API hostname. Instead, we expose a special-purpose endpoint directly on our main application's hostname. For example, /get API endpoint. When our single-page application first loads its index, HTML file in the user's browser, one of the very first things it does is make a single, asynchronous call to this endpoint. The Cloudflare snippet attached to this path runs, checks the user's country code, and instead of forwarding a request, its sole job is to construct and return a response. The body of that response simply contains the URL of the correct regional API, for instance, app1-api-eu.macloud.dev. The application captures this URL and stores it in a global variable or configuration object. From that moment on, every subsequent API call for data, fetching user profiles, submitting forms, loading content, goes directly to the correct regional endpoint. The Cloudflare logic doesn't need to run again. So, to recap the key strategies we covered, we secured our infrastructure to the highest standard using Cloudflare tunnels, intelligently routed traffic for complex architectures, and optimized our application for a global audience. By mastering these patterns, you can build truly scalable, secure, and performant web applications, allowing you to focus on what you do best, building amazing products. Thank you for watching this video from McCloud Academy.